Looking at linear inequalities, just the plain vanilla linear inequalities that we looked at last time. We can go through a step-by-step solution to those that looks very much like solving a linear equation. Simplify both sides, find a way to get the x terms on one side, the constant terms on the other, and isolate the x term on the left-hand side after we combine everything, and then divide both sides by the coefficient if necessary. The one thing we have to keep in mind, it's two things actually. If it's an inequality and we happen to be multiplying both sides by a negative number or dividing both sides by a negative number, we do what? Flip the sign. Reverse that direction of the inequality symbol, change the less than to a greater than or greater than to the less than. And then our final answer, our solution set. When we write our final answer to the inequality, we'll want to put in interval notation. And MyMathLab is pretty consistent about asking for the interval notation, and I'll be pretty consistent about asking for the interval notation on the test as well. We did several of those last time, and we also did a special type of compound linear inequality, which, since it involves the word and, basically negative 4 is less than 4 minus 2x, and 4 minus 2x is less than or equal to 12. Since it involves the word and that expression is the same in both of them. You've got a 4 minus 2x that has this relationship to the negative 4. It's greater than negative 4. And the 4 minus 2x, we also know it's less than or equal to 12. So we can say 4 minus 2x actually has to be between negative 4 and 12. And if it is, then x is going to work out okay for us. So we observed that we don't have to break it apart and solve them separately. Just make sure that whatever we do to each of those three parts, the left part, the middle part, the right part, we do to all three of those, and then we can solve it with a little bit less effort. So negative 4 is less than 4 minus 2x, which in turn must be less than or equal to 12. I'd like to isolate the variable term in the middle if we can, ultimately having just one x in the middle, but if we could start off with negative 2x in the middle, that would be a good first step. So what shall we do to all three parts? Subtract 4. We have that 4 in the middle, so if we subtract that 4 and then subtract 4 from each of the other parts, negative 8 on the left, negative 2x in the middle, canceling the 4 and the negative 4, and positive 8 on the right. Any need to reverse the inequality symbols? Not yet. Not yet. Still less than there. Still a less than or equal to there. Does look like we're going to need to divide all three parts by the negative 2. So to prepare for that, let's write a fresh copy of the negative 8, a fresh copy of the negative 2x, and a fresh copy of the positive 8. And then divide all three of them by negative 2. So negative 8 divided by negative 2, negative 2x divided by negative 2, 8 divided by negative 2. When we do that, we reverse each of the inequality symbols. So the less than turns into a greater than. The less than or equal to turns into a greater than or equal to right at the moment when we divide each one by negative 2. And then we just simplify. Negative 8 divided by negative 2, it's going to be positive 4. And just simplifying, no need to adjust the inequality symbols there. That's greater than x, and that's greater than or equal to negative 4. 8 divided by negative 2 equals negative 4. So this is our solution set. Now, if we want to write it just using inequality notation, we could maybe do a little bit better job. I like to see the intervals so that the left-hand endpoint is actually written on the left and the right-hand endpoint is actually written on the right. So what you might do is say this is equivalent to saying negative 4 is less than or equal to x. Now keep in mind, I'm not multiplying by any negative number here. This negative 4, actually, I'm just copying and pasting it over there. That's where that negative 4 came from. So get rid of the arrow. But negative 4 has this relationship that x is greater than or equal to it. So it, that is negative 4, is less than or equal to x. The x, since x has the relationship that 4 is greater than x is less than 4, so that 4 we get directly from over there. And this would be an equivalent way to write it, and it's a little bit easier in my view to take this and translate this into interval notation. We've got the left-hand endpoint of the interval on the left. It's the -4. Parenthesis or a bracket next to the -4. We need the bracket because of the or equal to bar. -4 is included in the solution set because of that or equal to bar, so we indicate that with the bracket. And then the 4, since the 4 is not included with the strict inequality, it doesn't have the or equal to bar, that one is just a plain parenthesis. So hopefully MyMathLab will be good with this. Call this a half-open interval. I suppose depending on your outlook on things, you could think of it as a half-closed interval, but half-open is typically the way we describe this. So here goes. Check that one, and then -4, 4, and check it. It's going to want the graph as well, I believe. Which one is it? It's, well, it's depending on, depending on how you count, it's the, it's the one in the upper right. It's B. -4 is the left-hand endpoint. +4 is the right-hand endpoint. So we'll check that one, and there we go. Let's see if the next question is okay. The last two, because they were the one we did today and the last one we did last time, because they were three-part inequalities, we could rewrite them using the word and. Well, here's an example of a compound inequality that involves the word or instead. 6x is less than or equal to -48, or x minus 2 is greater than 0. We can find a number that satisfies one of these, but it doesn't satisfy the other one. Would that be a valid solution to this mathematical statement? It's possible. There could be a number that satisfies one of these but does not satisfy the other. Would that be, if it's a good solution to one of these inequalities, would it be a good solution to the statement 6x is less than or equal to -48, or x minus 2 is greater than 0? Does it have to satisfy both or just one? Well, if we want to require that it satisfies both, we use the word and. Those previous two examples, in order to be a solution, it has to satisfy, if it's in the middle, it's got to be greater than the one on the left, less than the one on the right. Here, if it satisfies one or the other, but not necessarily both, it's going to count. So what we'll do here is we'll solve these two inequalities kind of independently of each other. We'll get an interval, that's a solution set to the one on the left. We'll get an interval, that's a solution set to the one on the right. And the solution set to the entire mathematical statement, this or statement, is going to be the union of those two. If we were graphing it, we would shade both of them on the real number line, and whatever got shaded at all would be part of the solution set. And if they don't overlap, we might have to use the union symbol to indicate the union of the two intervals that we find. So let's give this a look. Copy it down here. 6x is less than or equal to -48, or x minus 2 is greater than 0. Each one of these just takes about one step. 6x is less than or equal to -48. What are we going to do to both sides to find x? Going to divide both sides by 6. So copy the 6x, copy the -48, and then divide both sides by 6. Of course, we'll want to ask ourselves the question, leave the inequality symbol alone or reverse it? Leave it alone, because 6 is positive. And so we don't reverse the inequality symbol in that case. Simplify, and we get x is less than or equal to negative 8. The other one, x minus 2 is greater than 0. Add 2 to both sides. No need to reverse the inequality symbol there, just adding something to both sides. I'm going to bring down the OR statement and maybe copy it and bring down the OR statement as well. So if we find a number that's less than or equal to negative 8, or it's greater than 2, we've got ourselves a solution. Is there any number that you can think of that would satisfy both of these inequalities? Something that on the one hand is at or to the left of negative 8 on the number line, and also it happens to be to the right of 2. Can't be in both those places. So there's really no number that satisfies both of these, but there are a lot of numbers that satisfy either one or the other. If I were graphing it, and on the test, I'm not going to ask you to graph it. It seems like MyMathLab's pattern is to ask you for the graph after the fact, after you've already typed in the interval notation. I think the graph is far more useful to kind of wrap your brain around, well, what portion of the real number line are we actually looking at? Then write the interval notation. So the graph is everything at or to the left of negative 8 together with everything to the right of 2. So that's what the graph would look like. And if we want to indicate that using the interval notation, negative infinity to negative 8. Negative 8 is the right-hand endpoint of that interval. There is no left-hand endpoint to the interval. It just is unbounded to the left, so we use the simple negative infinity. A parenthesis next to the infinity, since negative infinity is not a number. Union, oops, almost messed that up. Union 2 to positive infinity. 2 is not included. X has to be greater than 2 if it's not less than or equal to 8 in order to qualify as part of this interval. And there's a trick, I think, to entering the union symbol, if I can remember how to do that. Save a little bit of clicking on the symbol palette. So if I didn't want to click on the symbol palette at all, I think I could do this. Negative front slash INF, there we go, for the negative infinity, comma, negative 8, and then the bracket. I want to say it's front slash, let me type it. Yes, spell out the word cup. Front slash and then spell out the word cup for, I guess what it looks like it might hold water or something like that. And then you don't have to click on the union symbol. I don't know if that's really worth it to you to avoid having to click on the union symbol, but there it is. 2, and then front slash INF, and then close the parentheses. So that's the solution set. Let's make sure it likes it. It does. And whoa, lots of choices. It's got to be A through D, maybe. Which one is it? It is C. Okay. How do you feel about this one? It's not bad? Okay. A little bit more of the same here, except that this is a special case. I think at a glance, without even having to write anything down, we could probably come up with a solution set. Never mind, I was thinking something else. We're going to have to write something down. My apologies. I thought it was going to be special, maybe all real numbers or no real numbers, but upon further review, let's give this a quick look. 2x plus 3 is less than or equal to negative 6, or 2x plus 3 is greater than or equal to 6. I would not recommend trying to solve this as a three-part inequality. And maybe that's the strongest thing I can say about this one. Otherwise, it feels kind of like the last example, and it feels a little bit redundant. But it looks like maybe we could do something like this. And be forewarned, as soon as I write this, I'm going to scratch it out. So this is what not to do. Maybe I should just say what not to do. What not to do. On the one hand, 2x plus 3 would work if it's greater than or equal to 6. Find any value of x that makes 2x plus 3 greater than or equal to 6, and it's going to satisfy this inequality, and since it's an OR inequality, it'll satisfy the whole statement. Being less than or equal to negative 6, having the expression be less than or equal to negative 6, means that negative 6 is actually greater than or equal to 2x plus 6. Doesn't that convey the same meaning as 2x plus 3 is less than or equal to negative 6? So I've seen it done where an attempt is made to solve this as a three-part inequality, where we get by with 25% less work. Instead of having to subtract 3 from both sides here and subtract 3 from both sides here, we just subtract 3 from all three parts. Seems like it should work, except that if we look at this statement and what it means, it's really an AND statement, not an OR statement. If I were going to take what I have right now and say, well, let's write this as two separate inequalities rather than two inequalities joined by some appropriate conjunction, rather than a three-part inequality, two separate ones, it would look like this. 2x plus 3 is greater than or equal to 6, and negative 6 is greater than or equal to 2x plus 3. So effectively, I've changed the OR to an AND by writing it like that. And the fact of the matter is, I don't think there's any number that satisfies this AND statement. Because if you find an x that satisfies 2x plus 3 is greater than or equal to 6, is 2x plus 3 then going to be less than or equal to negative 6? Can't be both greater than or equal to 6 and less than or equal to negative 6. So as soon as I write this as a three-part inequality, it's got no solutions. So that's what not to do. I guess I should leave it and then just kind of be a great big scratch that out. Let's solve it as is. 2x plus 3 is less than or equal to negative 6, or 2x plus 3 is greater than or equal to 6. Subtract 3 from both sides. 2x is less than or equal to negative 9. Subtract 3 from both sides. 2x is greater than or equal to 3. Keep the OR. Divide both sides by 2. Actually, copy the 2x and copy the negative 9, and then divide both sides by 2. And that's not going to affect the direction of the inequality symbol because 2 is positive. X is less than or equal to negative 9 halves. Likewise over here. X is greater than or equal to 3 halves, hanging on to that OR all the way down. Graph it first. Either x is less than or equal to 9 halves, or x is greater than or equal to 3 halves. And in interval notation, we use the union symbol. So very much like the last example, except don't be tempted to take the shortcut of writing it as a three-part inequality. If it's an OR, it really can't go that way. Three-part inequality means and we'll see that later. It's in a later chapter when we talk about inequalities that involve absolute value, but it really is an important distinction to make. I'm going to move past this one without entering the answer. And skip the one with the decimal. The equation 11.6x plus 13.6, y equals that, y equals 11.6x plus 13.6, estimates the amount that businesses will spend in billions of dollars on a certain business technology where x is the number of years after 2001. Okay, so we're not trying to tell the future here, evidently describing the a trend that's taken place in the past over the last 16, 17 years or so. For what years will the spending, or was the spending, more than $60 billion? What inequality symbol here do we need to indicate when this quantity has a value that is more than $60 billion? Greater than. Seems to me we want y, or 11.6x plus 13.6, to be greater than 60, because this is given in billions of dollars. X is the number of years after 2001. Seems like we could solve this for x and then interpret that in the light of the 2001. I don't think we need to incorporate the 2001 in how we set this up. We just need to think about what that means. Actually, I think we solve it for x, and it gives the 2001 right there. So I don't think the 2001 has to come into play. Subtract 13.6 from both sides. And 11.6x is going to be greater than 46.4. It would be great if that happened to be divisible by 11.6. I like nice numbers. Still greater than. 11.6 is positive. So we keep the inequality symbol pointing the direction it was pointing. X then greater than 4? Yes. Is it exactly 4 there? So as long as the number of years after the year 2001 is greater than 4, then the spending will be 60 billion. Then the spending will be greater than 60 billion. So the spending will be more than 60 billion, more than 4 years after 2001. There we go. Oops. It did it again. Just wanted to be below the x's. X is greater than 4. And I'm having a hard time with it. There we go. Acme Movers charges $200 plus $30 per hour to move household goods across town. That sound like a fair price to pay? You have a house full of household goods and you want to move across town? Would you pay Acme Movers $200 plus $30 an hour if they move quickly and efficiently and don't break any of your stuff or lose it? Maybe. Hanks Movers charges $55 per hour, but they don't hit you up evidently for that $200 flat rate fee, just straight $55 an hour. Guess we want to assume that they work with the same level of efficiency and professionalism, getting the job done. Assuming that, For what lengths of time does it cost less? Number of hours that Acme and Hank are on the job. For what lengths of time does it cost less to hire Hank's movers? Visualizing this, if we think about what Hank is going to charge and what Acme is going to charge, Hank, just a straight $55 an hour, so for 1 hour it would be, what, $55, and for 2 hours it would be $110. So Hank's charge function would look something like that, although if he doesn't break it down to fractions of an hour, it might be more of a step function than a straight line, but this kind of gives us an idea of how it would look. Acme, on the other hand, charges $200. Goodness, I'm going to have to edit my picture. Sorry about that, because I don't have a place to put $200. So let's do that and maybe push it down a little ways. I've got $110 right about there. So 200 is maybe right there. $200. That's what Acme charges. So $200. But for the first hour it's $35. So $235, and for the next hour it's another $35, if I remember that correctly. No, 30. There it is, 30. Okay, my dot, who can tell the difference between 30 and 35 at that rate? But let me say it right, $230, and then $260. Maybe I don't want to make it quite that steep. $230, $260, like that. At some point, Hank's cost is going to catch up with Acme's cost and overtake it. If Hank's workers drag their feet too much, at some point you're going to be paying Hank more than you would pay Acme. Let's see if we can see where that critical point is. If we move this up like that and we push this over there, at some point in time, wherever it is, then Hank will no longer be less than Acme. So we want Hank's cost to be less than Acme's cost. And we want to know for what values of x. If x represents the time it takes. You like x for a variable to represent time? Should we use little t instead of little x? Anyone have a preference? C for time? C for cost. Yeah, C for cost. I'm gonna go with x. Doesn't seem like a real strong preference to go with t there. So Hank's cost, if x is the number of hours, then I'm going to say $55 times the number of hours. $55 times x. And that's what I was trying to graph right here. Y equals $55 times x. Acme's cost, well, $200 right up front. And for each additional hour, $30. So you take $30 and multiply by the number of hours it takes Acme to get the job done. Add on the 200, include the 200, and we want to see for what values of x will Hank's cost be less than Acme's cost. Just a couple of steps to solve the inequality that we get once it's set up. Let's subtract $30 times x from both sides. $25 times x is going to be less than $200. We need x all by itself, which represents time, number of hours. So let's divide both sides by $25. Since the 25 has a dollar sign and the 200 also has a dollar sign, the dollar signs will effectively divide each other out. We won't have dollars on the right-hand side. X is less than 8. So if X is less than 8 hours, then Hank's cost is less than Acme's cost. So if we figure the job is going to take less than 8 hours, then Hank is the one, that company is the one to get the job done for less. It's going to take over 8 hours than Acme. Now, is MyMathLab going to want this in interval notation? Nope. Just the number 8 there. So it costs less to hire Hank's movers for times less than 8 hours. A little different one here. Kyle plans to invest $5,000. Part at 5% simple interest and the rest at 6% simple interest. Those are really close together. I don't know if we can, I'm just trying to imagine Kyle differentiating between the amount of risk that is going to involve in the 5% investment and the amount in the 6% investment. But evidently there is a difference. So what is the most that he can invest at 5%? And still be guaranteed at least $270 in interest per year? This looks kind of like one of our linear equations that we did in a previous section. So the total interest earned by the two investments has to be at least $270. What inequality symbol do we write that means at least? Yeah. If it's equal to, it's at least. If it's greater than, it's at least. So greater than or equal to at least $270. And so how much is he going to invest at 5%? Probably going to need to let X be the amount that he's going to invest at 5%. We can express the resulting amount that will be invested at 6% in terms of that, and then use both of those to calculate the total amount of interest. So if he's going to invest $5,000 and X dollars, or X amount of dollars, will be invested at 5%, how much then will be invested at 6%? How do you feel about $5,000 minus X? Yeah, that's in taking the one variable approach to this problem. We kind of have to come up with that $5,000 minus X. That's a real key to unlocking this problem. If you're looking at that and thinking, oh, what I'm coming up with that $5,000 minus X expression on my own, then when you get to this MyMathLab problem, or maybe you finished this MyMathLab problem many days ago, I don't know, but when you look at this, think about where that expression came from. If you invest $2,000 at 5%, then the rest, or 3,000, which you could get by subtracting from 5,000, has to be invested at 6%. So total interest earned by the two investments, that would be the interest earned by the X dollars invested at 5%. So interest equals principal, and the principal is X. Principal times rate times time. We're dealing with 1 year, aren't we? Per year. $270 per year, so 1 year is what we're working on. Plus interest earned by the 6% investment. That's going to be $5,000 minus X, that's the principal, to be invested at 6%, multiplied by the 6% interest rate, 0.06 when converted to a decimal, and then multiplied by the number of years, again, per year, 1 year. We need that to be greater than or equal to $270. And we've got ourselves a linear inequality. We can solve this for X, and the solution set, X, well, will X be greater than something? Will X be less than something? Let's see. 0.05X plus 6% of $5,000, $300 minus 0.06X. That's going to be greater than or equal to $270. If we combine like terms, the 0.05X minus 0.06X, negative 0.01X plus $300, that's greater than or equal to $270. But it looks like there'll be a negative quantity on the right-hand side when we subtract the $300 from both sides, so that's good news. Negative 0.01X is going to be greater than or equal to negative $30. At this point, if we were dealing with quantities on the two sides of the inequality and they had opposite signs, and depending on how this problem might have been stated, it's possible that we could be dealing with opposite signs there. It would indicate a negative amount to be invested, which simply means it's not possible. I would dare say if, let's see, we know 6% of $5,000, we just said is $300. Suppose Kyle wants to make at least $400 in interest. Well, if he goes with the entire $5,000 at 6%, he's just going to make $300 interest, so it's not going to happen. So I'm thinking right at this point we'd be facing X has such and such relationship to a negative number. Maybe X is less than some negative number, and we'd realize it was impossible. But I think this is going to be possible if we divide, actually copy the negative 0.01X and divide that by negative 0.01, and copy the negative $30 and divide that by negative 0.01. X is going to have what relationship to $3,000? Less than or equal to. We've got to reverse the direction that inequality symbol is pointing. So Kyle wants to make at least $270 in interest. If he puts too much in the 5% account, $3,500, $4,000, $4,500, $5,000, if he puts too much in the 5% account, he's just going to make at most 5% of that $5,000, which is only $250. Not going to make the $270 that he wants. But if he stays under $3,000 in the 5% account, that means enough will be invested in the 6% account to get him the 270 rather than just 250, which would be if he put the whole thing in the 5% account. So it'd be interesting how to express this. Well, MyMathLab goes ahead and gives us the at most. So a little bit of a spoiler there. If they just ask us for it, I'm thinking if I were designing this problem, maybe have a drop-down menu where the little at most is, and give you the option of saying at most or at least. That way, MyMathLab could determine, did you realize you had to reverse the direction of the inequality at that point? But it tells us at most, so he's got to no more than $3,000. So that's fine. Check it. All right. I was thinking about skipping that one, but there was a lot there. I don't know if I wanted to skip that problem. I might be able to skip this one, though. It's similar, that twice that amount at 2%. There's a little variation there. But I want to be able to have some time to talk about what to expect on the test. So let me skip over that one. Let's talk about Kurt. Kurt can be paid in one of two ways for the furniture he sells. Plan A, salary of $950 per month, plus a commission of 10% of sales. Plan B, salary of $1,350 per month, plus a commission of 15% of sales in excess of $9,000. Wow. For what amount of monthly sales is Plan B better than Plan A? Evidently, since it involves 15% at some point, if he sells enough, 15% of sales in excess of $9,000 plus the $1,350 is going to be more than 10% plus the $950. Plan B is better than Plan A when Kurt's sales are more than how much? Let's see. Plan B is greater than Plan A. I'm going to write that. Basically, Kurt's paycheck based on Plan B is greater than his paycheck, total gross pay, based on Plan A. So we need to express each of these in terms of X, his total sales. So let X equal Kurt's sales or total sales. How are we going to say that? MyMathLab just says sales. Plan B is greater than Plan A. So Plan A is fairly simple. $950 in a month plus 0.10 times X. The other one, that sales in excess of $9,000, that aspect of it I think is going to complicate this a little bit. So Plan B, $1,350 a month plus, if it were simply 15% of sales, this would be way better no matter what he sells, but we're only going to base that on sales in excess of $9,000. How are we going to write this? Why X minus 9,000?
Because you need the sales to be higher than 9,000. If it's less than 9,000, then you're just going to get you're not going to get any commission at all.
You think they'd give him negative commission if he sells less than $9,000 in a month?
No, you just wouldn't get any commission.
No? That would be cold, I guess.
That would be messed up.
It would, yeah. Okay. So we're gonna assume, I think, that Kurt's gonna sell more than $9,000 worth of furniture in a given month. Otherwise, we would have to make some modifications to the way we're writing the left-hand side. So basically, we'll look at sales. We'll subtract $9,000 there. So if he has $10,000 in sales, that would be $1,000 that gets multiplied by the 0.15. That would be $150 that gets added to the 1350. So $1,500 if he happens to sell $10,000, for example, in a given month. So I think that's the right expression. Take away $9,000 from the total sales, and you get the sales that are actually in excess of $9,000. Let's solve it. Simplify by distributing the 0.15 across the parentheses. $0.15 times $9,000. 1350, $1,350. That's greater than $950 plus 0.10 times x. There are some. Oh, if we combine the 1350 with the negative 1350, then it's exactly 0.15x. I wonder why they don't just say 15% of sales. I'm wondering if they might give him some negative commission if he sells less than $9,000. Keep his feet to the fire in a given month. Because otherwise they could simply say, okay, if you show up for a little bit or long enough for us to keep you around and sell $1,000 worth of furniture in a given month, if we want to keep you around, we'll pay you $150. Interesting. Okay. Let's subtract the 0.10 from both sides. Subtract 0.10x minus 0.10x. And we'll have 0.05x is greater than $950. Copy the 0.05x. Copy the $950. Divide both sides by 0.05. Keep the inequality symbol pointing the direction it was pointing because 0.05 is positive. And then x is going to be greater than $19,000. So maybe that's a good month. If Kurt sells $19,000 in furniture or more, if he sells more than that, then Plan B is going to be better than Plan A. If he sells less than that, Plan A is going to be better. $19,000. Okay, so maybe a little bit of a challenge right here toward the end of section 1.6, but if you've not already done those MyMathLab problems, hopefully this will help when you get to those.